My name's Cody Bahlau. I work on a research boat. It's run by Columbia University out of New York City. And we travel all around the world doing different science experiments and trying to further our knowledge about the ocean. How's everybody doing this morning? Can you all hear me okay?
Yeah.
Okay, that's good. So I'm from Michigan too. I grew up south of where you guys are at. I went to college in Michigan. I went to the University of Michigan. Who's a Michigan fan? Anybody in the class?
Me.
Yeah. Everybody else is Michigan State?
Yeah. Yeah.
Or neutral.
All right. So we're going to talk about a few things today. We're going to talk a little bit about sort of the ideas of ocean literacy, meaning the understanding of the ocean and how it sort of affects what we do. We're going to talk about life on board a research boat and a little bit about careers as well. So, how one would sort of find themselves in a research boat or more broadly into the science fields. So first off, we'll start a little bit about ocean literacy. So there are sort of 7 ideas of how we understand how we impact the ocean and how the ocean impacts us. We're not going to go through all of them. We're just going to pick 1 or 2, and we're going to look at those sort of as we go. So if you look at so the first principle, one big ocean, it's sort of how the oceans connect us and how we're connected. So how many oceans are there? Does anybody know?
7.
5.
So there are actually 5. So there's the Pacific, the Atlantic, the Arctic, the Southern, and the Indian Ocean. But sometimes when you look at a map, they're split like we see here. They're split the North Atlantic, the South Atlantic, the North Pacific, South Pacific. But there are 5 oceans. And how that sort of affects us is when we look at the currents. So before we run into that, let's look where the boat's at so we can kind of have an understanding of where the research boat's at. So I'm going to share my screen, and we're going to look at Google Earth. So this is Clarkston, Michigan that we're looking at right now. Hopefully it looks familiar. So we're going to zoom out as we go. So as we all know, that's the state of Michigan, of course, with the Great Lakes. We're going to keep coming out. That's the United States. And our research vessel is the RV Marcus G. Langseth. And right now we're in port in San Diego. So what port means is we're tied up alongside a dock and we're doing different maintenance. So this is our time to get fuel, to get food on board, to change out scientists and crew, to get more equipment and gear for scientific experiments. And one kind of neat thing. So does everybody see the boat here, Marcus G. Langseth?
Mm-hmm.
Yep. So just below us or just south of us, you can see these little square pens. These are where the Navy trains dolphins to work with the Navy and swim into different harbors and look for different things, similar to how the police use dogs, but the Navy uses dolphins, and this is where they're kept. Isn't that kind of cool?
Yeah, that is crazy.
It's different. Yeah. So we're gonna be here for a few more days, and then we're gonna leave port, and we're gonna sail all the way down to off of Mexico. So the United States up in the north, and then we have Mexico down here. So we're gonna come all the way down here to this zone right here. It's called 9 North, and we're gonna do some scientific experiments there, and we're gonna be there for about 40 days before we then have to go back to port again after the expedition is done. So we're going to have 45 people on board the boat, and we're going to be gone for, like I said, 40 days. So we need to have enough food and fuel, equipment, supplies to be able to go out and do that. So along with that, so now we're sort of looking at the Earth, the oceans, Pacific, the Atlantic. Then we have the different sort of depths of the ocean, or the different layers. So let's have a picture of that. So here, obviously the ocean is quite deep. So the deepest part, 11-ish thousand meters, is the Marianas Trench. It's in the Pacific Ocean. Does anybody know the deepest part in the Atlantic Ocean?
Any guesses?
Bermuda Triangle.
What did you say?
Bermuda Triangle.
We have a guess of Bermuda Triangle.
Close to the Bermuda Triangle. Yep. Let's have a look. You're very close. So the Bermuda Triangle sits right here. So I don't have a layer to add for it, but this is where it's at. And on the southern end of the Bermuda Triangle is Puerto Rico, and then the Puerto Rico Trench is right here, and that's the deepest part in the Atlantic Ocean. So yeah, that's a very good guess. Who said the Bermuda Triangle? So this is around 8,000 meters. So remember, a meter is roughly equal to a yard. So let's call it 8,000 yards deep. That's quite deep, isn't it?
Mm-hmm.
So if we go back to our picture of the ocean zones, so let's look at that. So we have the sunlight zone, which is sitting at 100-ish meters. You have your twilight zone down to 1,000 meters, and you can see in the picture the different type of marine sort of animals that we're going to find in those zones. The 4,000 meters is the midnight zone. 6,000 meters is down to the abyss, and then you have the trenches. So my boat, the RV Marcus G. Langseth, we work in anything from the surface all the way down to 6,000 meters. And we drop equipment over the side, or we deploy equipment into the ocean, and it floats all the way down to the bottom. And we take different scientific measurements when it's sitting on the bottom. So we do two different types of main science. We do geophysics or geology, and we do oceanographic type measurements. So let's look at sort of the two types. So the geophysics, geology, that's sonars, that's seismic data. So what's sonar and seismic? So basically we make a noise and we measure the reflection that comes back, and we can make an image of the rocks below on the seafloor. So think of like how a bat flies through the air. So a bat flies through the air, you know, it makes a noise, and then that reflection comes back and it listens to the reflection, and then it can see the tree or a barn or a house. Well, we do the same type of technology, but we make the noise ourselves, and then we can make an image of those rocks. We'll look at a few more pictures later on, but I don't want to get too much into it right now. In the oceanographic type measurements, we take seawater samples. We take, we have different instruments that can measure temperature and salinity. We can measure the oxygen in the water. We can measure the light in the water. So if we look at the picture that we're seeing right now, so the sunlight zone, obviously we're getting sunlight there. The twilight zone, the sunlight is all but gone. In the midnight zone, there is no more light at all. So we have an instrument that as it goes down, we can see what type of light penetration gets in the water. And that's done by, of course, the turbidity in the water. So how much suspended sediment is in the water, so that blocks that sunlight as it goes down. So we have all sorts of different instruments that we can sort of look at the different properties of the ocean. So let's move on. Let's look a little bit about the boat. So I've mentioned it a few times now. So we'll go back to our principles. So that's principle 7, which is the ocean is largely unexplored, and the main characters or the main players in the exploration of the ocean are research boats like mine. So my boat is part of UNOLS, so it's a part of a university system that has research boats all around the country. Some research boats only go off for a day or two. Some research boats go off for 30, 40, 50 days at a time. So let's have a look at the Marcus G. Langseth. We're going to watch a video. So this is a drone video, just like a helicopter flying over the boat. And as we go, I'll explain as we go. So right now, we're coming up on the back of the boat, or the stern. So offshore, we have all these different names that most people don't use on shore. So stern is one of them, means the back of the boat. We're coming up on the right-hand side now, which is called the starboard side. And as we come up on the starboard side, you're going to see a gray square in the middle. So that's called the A-frame. We're going to see it here in a second. So that's called the A-frame, and that's what we use to deploy equipment off the side of the boat. So once again, deploy is when we put something into the water from the boat. Now we're coming up onto the front side of the boat. That's called the bow. So if anybody can see that dark blue line at the top, and right below you can sort of see the windows. So that's the bridge, or that's where the captain and the bridge officers drive the vessel. So the captain's up there, and then he has the first, second, and third mate that help drive the boat as we go. They work in shifts. So we're coming on the port side now, or the left side of the boat. So you can see two smaller workboats hanging off the davits there. And right in the middle, you can see a big tower. We'll talk a little bit about that later, but that's where the PSOs work. PSOs is protected species observers, and they look for different types of wildlife when we're doing our scientific expeditions. Because when we're out doing science, we don't want to harm any of the wildlife, of course, as we're collecting data. So we have special trained biologists who come on board, and they monitor the sea around where we're working to make sure that we're not too close to dolphins or whales or sea turtles and even seabirds. So that's some of the work they do on board. And we're going to talk about a couple different ways that sort of people can get into the research world later on. And one of those is biology. So let's look at some of the interior shots of the boat here. So as I mentioned before, we're at sea for 40 days. So you need everything to be able to live. So right now in your class, there's 27-ish people. So imagine 2 of your classes all living together for 40 days. And size-wise, so the boat is about 75 yards long, so just a little bit shorter than the football field, 75 yards by 20 yards wide. So I don't know, what would that, maybe like your gym? So 40-ish people in your gym for 40 days. That'd be pretty tight quarters, wouldn't it?
You've got quite a lot of looks at the everybody's looking around right now.
Yeah. So let's look at a few things. So at school, you guys have your cafeteria, right? So we have something similar on board, but we call it the mess room. So this is where we're going to eat. So they have 3 meals a day, breakfast, lunch, and dinner, and they always have snacks. We have a salad bar. We have an ice cream cooler. So like a common meal, we would have pizza and chicken wings. Or, for breakfast, we have eggs and pancakes and bacon and fresh fruit. So just like similar to like a restaurant type situation. Where they cook, we don't call it the kitchen. We call it the galley. So let's have a look at that. So this is the galley. So it's probably a lot smaller than your school's cafeteria, but we would get a plate, and then you just sort of pick whatever type of food you want. There's always a couple hot options. There's usually a vegetarian option. So it's, we try to obviously have food for everybody when they come on board. So a couple other things for the cabins. So this is an example of where the scientists stay. This is one of our cabins on board. So this cabin sleeps 3 people, and then they share a bathroom with another cabin that sleeps 3 people. So 6 people all sharing one bathroom at a time. So as you can imagine, you need to be polite and use your spaces so everybody can use the space at the same time. So also when we're on board, we work in shifts. So when the boat sails, it's operating 24 hours a day. But so everybody doesn't work all at the same time. So some people may have breakfast, some people may never see breakfast, and they only see dinner. So depending on the person and depending on what they're doing, the shifts could be 12 hours a day. So they could start at noon, end at midnight. They could start at noon, end at 8 p.m. And then the next shift comes and works from 8 p.m. to 4 a.m. Or they could work 4-hour shifts. So they could be the noon to 4 p.m. shift, and then they get back up at midnight and work midnight to 4 a.m. shift. So there's a lot of different ways to rotate people through a 24-hour cycle, but the boat never sleeps, essentially. There's always somebody working at all times. So let's look at a few more pictures here. This is the bridge. This is where the captain is up driving the boat with the other bridge officers. So what's something that you would expect to see up there that you don't see?
People are saying steering wheel.
Buttons. Those buttons.
Yeah, exactly right. So there's no steering wheel, right? So everything is done now with someone mentioned the buttons and small little, essentially joysticks. So it's just like playing a PlayStation. Gone are the days of the big steering wheel. Now we just have a little joystick that the boat drives back and forth. So they can control the speed, they can control the direction, all done with essentially a PlayStation controller. So it's quite a modern boat, and they have all different types of equipment up there. They have radars, and they have electronic charts, and they have radios and all things like that they would need to be able to drive safely. Because you remember at night, they could hardly see anything out the windows. So they have the radar and other type of equipment to be able to see other vessels in the area as we sort of transit from place to place. So a few other things. Let's look. So when you're not working, you have the movie room. So we have a TV with Netflix and Amazon. We also have several hundred movies and TV shows. We have guitars. We have PlayStations. We have games, Monopoly. So it keeps. We try to keep people to at least have some fun and some down. When they're not working. Another example would be the gym. Yeah,
Can
go
I
ahead.
interrupt? We have a couple of questions.
Yeah, let's do it.
Yeah, Ben.
What time is it for you?
So right now I'm in Colorado, but the boat is in San Diego, so it's Pacific time. So on the vessel time right now, it'd be 7:20.
Oh,
They're in the wrong time right now. Not Eastern time right now. Leo, do you have a question about the boat?
I was gonna say what's the most important thing you need to know when you're working?
Okay. What's the most important thing you need to know when working?
Wow, that's a good question. So I would say every role is going to be different on board. So whether you're an engineer down in the engine room, or whether you're up on the bridge driving the boat, or a scientist doing experiments, I would say the most important thing to know is that you don't know everything. And if you do have a question, it's best to find the answer, ask questions, because usually accidents happen, offshore on a vessel like that. Safety is a very, very important thing. We're a long ways away from shore. We're sometimes 4, 5, 6 days away from a proper hospital. So if someone were to get hurt, it's a big thing. I'll show you. So we have a hospital on board as well, but the most important thing is to work safely. So if you don't know something, you need to step back and you need to maybe read a manual, read a book, ask a question to be able to make sure that you can work safely. Does that sort of answer your question?
Yeah.
Yeah. So this is our hospital on board. So the captain is the main medical provider. We have a small hospital with all different types of medicine and equipment that the captain can help if something were to go wrong. They can help out in that situation. So yeah, this is a library as well. And that's probably it for the boat tour. Any more questions about? I have more questions, or I have more pictures as well. But any more questions on the boat?
Nope, no questions about the boat.
Okay. So when we do the different types of science, some days it's flat and some days it's quite rough. And you just have to see what the seas look like at the time. But here's an example of sort of a rough day. Who would like to work in this type of weather?
All hands, hoist the colors high. Heave ho, thieves and beggars, never shall we die.
Who would like to work in that type of weather? Everybody?
Me. Yeah, that'd be awesome.
Yeah. No, I'm not trying to die to a hurricane.
It can be. Here's another picture here. What about that? You see the water on deck?
That's refreshing.
Yeah. So what we're doing right there is we're deploying OBSs. So OBS is ocean bottom seismometer, and we drop this piece of equipment into the ocean, and the ocean is so deep at places that it takes 2 hours for it to even drift to the bottom of the ocean. That's a long time, isn't it? So let's give you a picture here. So this is what it looks like when we deploy that.
You have been the one for me. Goodbye, my lover. Goodbye, my friend. You have been the one. You have been the one for me.
So that drifts all the way to the bottom, and then we're able to take different measurements when it's on the bottom. So let's do a couple pics of some other stuff that we do. So this is an ROV, so it's remotely operated vehicle. It's a big submarine that we can send down to the bottom of the ocean. We can take samples, we can take pictures, we can place things on the bottom. Here's a picture of the control van, or a big instrument van where we can see the different camera angles of that ROV. Let's see, what else do we have? This is what we call a multi-core. So we send it down to the bottom. It almost looks like something that lands on the moon. So we send it down to the bottom, and we can take soil samples. So this is a tube of a sample of the soil that's on the bottom. So it's very, very soft, but with this particular tool that we can take it and the scientists can study. sort of that seawater bottom interaction. Let's look at one more picture of what we can do. So this is called dredging. So we send a big basket down with chains and metal teeth. It almost looks like something that you'd see on a bulldozer, and we drag that across the bottom of the ocean, and we can bring back rocks that the scientists can then study to look at what type of rock formations are down on a particular mountain or something like that. So those are some physical samples we can take. What are some other things we can do? We can, as I mentioned before, we have the sonar. So the sonar, we make that noise, and then we can make a map of the bottom of the ocean. So let's see. Let's look at one example of that. Hold on one second. Here. So when we look at something like Google Earth, so that's be on the bottom here. Let me just share my screen and I'll show you. So when we look at Google Earth, we zoom in, and you think everything has been mapped on the ocean, but that's not quite true. So does everybody see the difference in this fuzzy area as opposed to here where it's a lot clearer and we can see a lot more detail? Does everybody see that? Yeah. So the fuzzy area has actually never been mapped. It's unknown. And the way that we're able to see features here is a very cool technique. They actually use satellite data to get an approximation of the bottom of the seafloor. It's called satellite altimetry. But here where it's very well defined, this is actually sonar data that a research boat like mine has actually measured. So the satellite data, while not very detailed, is amazingly good for something that they can do from space. And they do it by looking at the height of the ocean, the very, very small differences in the height of the ocean. They can predict what the bottom looks like. It's actually quite an amazing technology. But when we zoom out, a lot of the ocean actually hasn't been mapped. So does anybody know? So the ocean is 71-ish% of Earth. Does anybody know how much has actually been mapped? Can you give me a guess?
Nolan, what's your guess? 5%.
A little bit higher than 5%.
Okay. Molly?
Like 6.5.
6.5?
So it's actually 27%. Yep, 27%'s been mapped. So here's a picture here. So this is from an organization called Seabed 2030 and JEPCO. And their mission is to have all of the oceans mapped by 2030. Now, it's not going to happen right now, but it's a goal that we want to put forward to be able to have awareness of what can be mapped or what has been mapped in the oceans. So you see here in our picture, all the black spaces, those are all spaces that have never been mapped. And all the light blue spaces, so next to different countries, next to the U.S. on the East Coast, this is Hawaii here, so that has been mapped. But you can see all the different black spaces that has never been mapped. So it's truly an unknown area. So yeah, so that's part of sort of the exploration and part of what we do on board the boat. So this is a picture here. So these are two interns. They just graduated college and they came offshore on board the research boat, and we did some mapping together. So yeah. Okay, let's stop there for some questions.
Jack?
How do you guys map it exactly?
How do you map it exactly? Is it just the sonar, or is there more?
So we have a couple different types of sonar on board. So the main one is the EM122 multi-beam. So the multi-beam, instead of sending one ping down and getting one ping back, and we just have essentially a line across where we sail, the multi-beam sends a different phase out, so we can change how many degrees we want. And based on the water depth, we get a larger footprint. So if we're in very shallow water, how much we can see, maybe only 100 meters. But in very deep water, it may be 10 kilometers across that we can make an image of the ocean. So here I just put up a screen of that actual instrument. So on the top two pictures, that's a screen capture from that piece of equipment as we measure the data. And on the bottom picture here, that's Google Earth with the new data overlaid on top of Google Earth. So you see, so Google Earth is the dark blue, what we were just looking at. The light blue area is the brand new data that nobody had ever seen before until we mapped it. And then you can see the direct correlation on the actual instrument on the left. So you see my You see my red arrows there? Does everybody see that?
Mm-hmm.
Yeah. So
Okay. Does that answer your question, Jack?
Yeah.
Okay. Thank you. We have another question, Ben.
Has anyone ever been overboard, like hit by a wave and gone overboard?
Like
So-
with the crazy waves. Did you hear the question?
Yep.
Okay.
On our vessel, no. It does happen in the broader maritime world. On our vessel, no. We try to manage the safety very well. When we're working close to the side, we're wearing life vest. When we're working close to the side where the side is exposed, we wear a tether, so it attaches to our back and attaches to the ship. I don't know. Maybe some people have seen people working on a roof with something like that. So let me show you this video, and if you look real close, you can see the guys wearing it. Did everybody see the tether on the back of the guys? Yeah. And they're also wearing, I don't know if you noticed, they're wearing high-vis clothing, like my coveralls that I'm wearing now. The reason that it's orange and the reason that we have strips on our shoulders, that if someone does go in the water, when we're shining the spotlight, the person is easier to see. So we have a lot of different things in place to help us work safely and to make sure that doesn't happen.
Okay. Ethan?
What do you do in particular?
The question is specifically, what is your job? More specifically.
Yep. So my job on board, so there's a couple different categories on board our research boat. There's the maritime crew. So that's the captain, the chief engineer, just like almost Star Trek. And then there's the science and the technical group. So I'm part of the technical group. My title is a chief science officer, and I manage the technicians when they're on board. So think of technicians like they're sort of IT support, but we're also making sure all the scientific equipment works. We're helping to deploy the equipment into the water. So that's the group that I work with. And then I also work with the scientists who come on board from all the different universities to make sure that they can achieve their goals when they come on board the boat. Does that make sense to you?
Yeah.
Okay.
Yep.
Miles?
Do fish sometimes interfere with like the sonar?
Yeah. Well, that's a fantastic question. So let's go back to that picture of... So on the right-hand side here, so we've already looked at this one. On the right-hand side, this shows the water column. So at the top of the pyramid is the boat. And at the bottom, that sort of that red line that you can see that I have labeled seafloor, that's the bottom of the ocean. So if we see a big school of fish, we'll pick it up in this water column. So we'll see them swim by. We'll also see if there's any gas leaks coming from the bottom of the ocean. We'll see that as well. So I mentioned the PSOs before. Part of their job is to make sure that we don't harm any wildlife as we're working. So they're always looking, they have big binoculars. They're looking for different animals as we go. So this is a picture of a dolphin they did. This is a sea turtle. What's that? Another dolphin. Here's a picture, or here's a small video of some whales. Hold on one second. Here they come.
Absolutely not.
There they are. Yeah.
Stop.
Okay. We have more questions?
Yes. Leo?
What's the closest estimate to how long or how far you travel in a year?
So how far does the Marcus G. Langseth travel in like a year?
Yep. So every year is a little bit different. It depends on what region we work in. Let me see if I can put this layer in. Hold on one second. Here it is. Yeah, so every year is a little bit different. It depends on what region we're working. So what we normally do is we tell the science community, hey, in 2024, we're going to be working in the Pacific or something like that. And then they go out and they then sort of find work for the boat. So let's look. So that's a good question. That's the first time I've ever had that question. Let's look at Google Earth. So I've just added our work for 2024. So right now, this is the Earth. There's no lines on it. So I add the layer. So in the beginning of 2024, we started on the East Coast of the U.S. We went all the way down to Africa. So all these colored lines are the vessel track for that year. We came up to Iceland. We were over in Lithuania, and we came back down here to the islands off of Africa called Cape Verde, or Cabo Verde in Portuguese. Does that answer your question?
Yeah.
Does it look like a long ways?
Yeah.
Yeah. Good.
Any other questions before he moves on? No questions.
Okay. So I know you guys talk a little bit about careers. Is that right?
Yes.
Yeah. So what's one of the main topics you're learning now?
Business management and marketing, somebody just said. That's our current unit.
Okay. Oh, that's a good one. Yeah. Marketing's important. So right now you guys are in 6th and 7th grade. So middle school, junior high. So I'm going to talk a little bit about how to get sort of in the broader sciences in a research boat, but it really applies to anything that you're interested in. So for example, for a research boat, you when I was in your position in 6th grade, I didn't know what I wanted to do when I sort of grew up, let's call it. But I knew there were certain things that I had interest in over other things. So for me, for example, I like to learn about science. I like to look at maps. I like to understand the rocks, around Michigan. So because of that, I took more classes in earth sciences. I like shop class and things like that. And then when I went to high school, I took biology and chemistry. I took geography. So there were certain things that I was interested in, and that sort of moved my focus to what I did today. But like I said, like when I was in your shoes, I didn't know that my job even existed in this world. But there was things that I was interested in that sort of moved my path. So I went to a junior college after high school. So it's, junior high, high school. And a junior college is a college, but it's a little bit smaller down in Jackson, so south of you guys. And then I ended up going to University of Michigan, where I studied geology. But I think what I want to show is there's many different ways to be able to get where you want to do in life. So when you leave high school, so on the left-hand side, you see high school. And then there's many different ways, for example, to get on a research boat. You can go to a trade school. You can learn welding. You can learn engine maintenance. You can go to university and do biology. You can do like a maritime academy and become a captain or an engineer. For data or tech, you can learn AI. Everybody's talking about AI now and coding. It's quite important. You can go to the military. So this is just one job on a research boat. But I think the bigger picture to take away here is there's many different paths in life to end up sort of how you want to get there. And I think the most important thing is to work hard and stay curious and to sort of keep that focus going forward. Yeah. Does anybody have any questions about that? I know it's specifically about a research boat, but I can answer more if you have more business questions.
Questions about that? No questions.
Okay. Another thing about sort of the offshore world is what we call the blue economy. So there's lots of different things that people do in and around the ocean. So, in this little picture that we see here, there's, of course, tourism. I don't know if anybody's been on vacation to the beach, probably. So there's tourism, there's scuba diving, there's fishing. There's also industry that we do offshore. So there's the wind industry, there's the oil and gas industry, there's fishing, there's transport, there's working at the docks. So what's been called in the last, I would say 5 years, everybody's beginning to use this term, the blue economy. And it's just a word to be able to capture all the things that happen both on the ocean, but also in the Great Lakes as well. So in the Great Lakes around Michigan, you have transportation, you have fishing. There's a research boat like mine. It's much smaller, but it's up in Lake Superior. It's run out of Minnesota. So there's lots of different things that you can do working sort of in the general offshore world. So here's another picture. What do you guys think this is?
Ben, what do you think?
Ship rope.
Ship rope.
Yeah. So just like back in Michigan, where you have 27 and I-75 and things like that, where all the density of the cars are, the oceans have the same thing. So there are large areas of the oceans that hardly boats ever go in. And there are spots of the oceans where they're very, very busy, and they're called shipping lanes. So you can see from this picture, you can see the density of the different shipping lanes as they go. So the darker red color it is, the more ships over time sort of work in that area. So you can see, you know, back and forth between the United States and Europe, for example, or through the Panama Canal. Does everybody know about the Panama Canal and why it's so important?
You have some shaking head yes and some no.
So before the Panama Canal, which was built in the early 1900s, if you wanted to go from New York City to San Francisco, how would you get there?
What would you do, Jack?
You would literally have to go all the way down to the tip of South America and then just go all the way back up again, which is very time consuming and very dangerous.
That's right. Yeah, that's 100% correct. So down at the tip of South America, the seas are very dangerous. And obviously more time at sea is more money. People are losing time for their businesses. So they came up with the idea to make the Panama Canal. So let's see. Let's zoom in on that. We won't talk about it too much, but I do have a time-lapse video, which is kind of cool. So I'll share Google Earth again here. So you're talking about business and class right now. Just imagine if you're running a business and you had to ship something all the way around South America and to come to San Francisco, how much longer that would take, how many more supplies you would have to send that were en route over time. So it's a long time and a lot of money involved. So here's Panama. So here's the Panama Canal, which sits right in here. And so in the early 1900s, they dug a canal to be able to cut down on that transportation time. So they're able to move a lot more supplies a lot quicker. So let's look. I have a time-lapse video of the Marcus G. Langseth going through the canal. So there are several locks, and a lock is a way to raise the boat different heights. Does everybody know that? I have an animation as well. So here we go. So let's look at this graphic of this animation. So on the left-hand side, you see the boat come into the first lock. So it comes in, they shut the door. The lock is then flooded, and it raises the boat up. They then open the door to the second lock. The boat sails in. They close the door. They then flood the second lock, and the boat raises again. They then go into the third lock, close the door, flood it, raise it. So it's a big boat elevator. Isn't that kind of cool?
Mm-hmm.
Yeah. Any questions about that?
Jack?
Can locks malfunction and cause bad things to happen at all? Like it doesn't, for example, like it floods, but then it suddenly won't stop flooding.
So they have, yeah. So it's a good question. They have safety measures in place. So if the water starts to go too high into another lock, just like think like a hot tub or a bathtub. So if you start to fill the bathtub and it gets so high, there's that hole by the faucet that the water can then flow through and drain out. You know what I mean?
So they have fail safes.
Yep. Yeah, so the water is able to drain out without over flooding the lock.
Awesome.
Yeah.
We've got about 4 or 5 more minutes.
Okay. So let's look at one more video, and then we'll just do questions then. A lot of the places that we work are quite interesting. So last year we were in the Galapagos Islands, and we're able to take some time and see the islands and be a bit of a tourist. So when we were there, this is some of the video that we took. So this is some of the crew snorkeling. There's, I think, a black tip shark. Is that right?
Mm-hmm.
Then we see sea turtles. And this iguana, a tortoise. Here's another tortoise. So he has number 1 on his shell. He's the fastest. And a couple locals here sleeping on the park bench. And a couple lava tubes. That's about it. Yeah. Okay. So let's do questions until the end. Does anybody have any business-related questions or marketing?
No, but we do have another question. Did you have a question? Yeah, go ahead, Matt.
Do you ever get like vacation?
What is your vacation or time off like?
So I'm on board the boat 180 to 200 days a year. Now that's not all at one time. It's usually 4 to 5 weeks, and then I'm home for several weeks and then back on board. So I leave back for the boat on Friday, and I'll be gone for 5 weeks. Tomorrow. I leave tomorrow.
Okay. Other questions? Yeah, Jack?
Is there anything dangerous that's like not on the surface? Because the weather can't really affect below the surface, and like you're just kind of floating in the middle of the ocean. Like, what kind of things that could go wrong? What things could go wrong if you're not on the surface?
So the cap up on the bridge, they have what's called ECDIS, which is the electronic charts, and they're able to chart our path as we travel. Because you're right, even out in the middle of the Pacific Ocean, there are very, very small islands that just come below the surface that if you weren't watching your charts, you could easily hit. So it's called a navigation hazard. On all the charts, those particular navigation hazards are highlighted for shipping concerns. And even on Google Earth, you can drop some layers in to be able to see what exists sort of in the ocean. Now, you're not supposed to travel or navigate by Google Earth, but it's another tool that we can use as we go. Another tool for the weather you mentioned is called Windy. Let me share the screen. Hold on. So this is a tool that we use to look at the weather. It's called windy.com. You guys can look at it as well. So right now I have the wind layer on here. So you can see the darker colors. There is a faster wind speed. So what's this? This is 45 miles an hour or 45 knots. So when we leave San Diego and we transit down to our work area, I'll be looking at the weather along the way to see what the wind speed is and also to see what the waves. So this is the wave layer here. Hold on one second. It's taking a while to load. But we can look at the wave layer and see what the wave. Oh, here it is. So off California right now, it's 4.5 meters. So that's fairly considerate. We would have to watch what we're doing when we either transit through that area or when we deploy the gear in that area. Yeah, that's a good question, Jack. Any more?
I don't think so. Oh, one last one. Go ahead, Miles.
Well, what's like the best thing that you've ever done?
What's the best thing you've ever done?
Well, we've been to a lot of neat places. The Galapagos were very cool with scuba diving and seeing all the wildlife. We were in Cape Town, South Africa, was very nice. But probably one of the neatest things I did, we transited from Cape Town all the way to New York City. So that was a month at sea. It was 30 days. We were going full speed the whole time. We crossed the equator. When you cross the equator at sea, there's a special ceremony that you have to do. It's called becoming a shellback. So for those who haven't crossed the equator, you're called polywogs or little tadpoles. And then when you cross, you're then inducted into the halls of Neptune as a glorious shellback. So that was pretty fun.
That sounds great.
Yep.
Okay. Wow. Thank you so much for sharing about your career. I know that they have a lot of questions, and I know that they'll have a lot of good conversation tomorrow.
Good. I hope so.
Okay. I'd say thank you to Mr. Bahlau for sharing.
Okay. Thank you.
so much.
Okay. Bye-bye. Bye-bye.
Goodbye.